Good morning, everybody. We'll be getting started here in just a minute. Okay, just a quick test. If you can hear my voice and see my PowerPoint slide, go ahead and raise your hand for me. All right, so at least a good chunk of you can hear me. So thank you for that. We'll go ahead and get started. As we go through today, people, if you have any questions, feel free to ask them using the Q&A box there in your Zoom interface. I cannot easily see chat or hands raised as we go through the presentation, so use Q&A. I've got enough room on my screen to see that. And hopefully today's webinar goes better than my last one where my router rebooted on me, beta testing just as we started. So today we're talking about our Wi-Fi 6 family of access points. So I'm going to start by talking a little bit here about just Wi-Fi history in general. So Wi-Fi originally got defined back in 1997 with a max speed of 2 megabits per second. It was a very different time back then, web browsing was just sort of catching on, going mainstream. We were at the peak of the initial tech boom there, where everybody and their sister put together a website and hoped to sell it for millions of dollars. But when it came to Wi-Fi, there weren't a lot of devices out there. There wasn't a lot of plans for speed. Nobody was streaming video, things like that. And unfortunately, as time has gone on with these new standards, 11G, 11N, 11AC, it's all been primarily building on top of that original 1997 spec. So they've been adding stuff where they could fit it in without modifying it. So Wi-Fi 6, otherwise known as 802.11ax, it's really the first major overhaul given to the platform from the early days. It changes a number of things in the 802.11 spec for the better and solves a number of the issues that we've had over the years, particularly when dealing with either a large number of users in a small area or a large number of access points in a small area. So anywhere where the Wi-Fi environment itself is crowded. So that takes us to this slide here. And that's why we're saying we're going from contention-based to contention-free. We'll go through some of the individual technologies here in a few more slides on how we do this. But basically, it's designed to sort of solve those issues of too many devices trying to transmit at the same time using shared frequencies, the interference that causes, the drop packets it causes, particularly the problems it causes with voice over Wi-Fi, something that doesn't use a lot of bandwidth but is highly sensitive to drop packets and latency. So with Wi-Fi 6, the theoretical maximum speed is bumped all the way up to 10 gigabits. I don't think anybody yet is shipping anything that supports this, but that's where the spec goes. It's designed, as we were talking about before, for larger capacity, both in terms of number of users and just the number of access points in an area. And it works on both the 2.4 and the 5 gigahertz spectrum. So 11AC, the previous spec that we've been deploying, only worked on the 5 gigahertz radio. The 2.4 gigahertz radio has still been operating using the 11N spec or Wi-Fi 4. So Wi-Fi 6 jumps us up to handle both of those. Wi-Fi 6 in theory can work with any frequency with very little modification. So one of the things that you've probably heard a little bit about is something called Wi-Fi 6E, the E for extended. So the FCC recently opened up a huge chunk of spectrum in the 6 gigahertz space. So you'll soon be seeing products coming out that operate in that 6 gigahertz space, probably at first on the consumer side of things, but eventually you'll see business products moving in that direction as well. Um, it opens up a lot of space, but there's still some technology hurdles there because it's much like a big chunk of the 5 gigahertz spectrum. There are already users of that 6 gigahertz space, so the spec has to take into account those current users not using Wi-Fi technology and how to deal with them and not degrade their performance. But you will start seeing that stuff coming out here really soon. Tim had a question here, was asking if 6E is CBRS. So no, CBRS is something a little bit different. CBRS is community broadband. So basically it's a low powered LTE. So it's a competitor or goes along with LTE and 5G technology on the cell phone side of things. So that's what CBRS is. Um, Depending on the power output and some things like that, you don't need a license to do that. So you can deploy your own LTE. So Wi-Fi 6E is still Wi-Fi based using the 6 gigahertz platform, and it will be license free. But like I said, there's some technical hurdles in the background that make it so it needs to be able to play nice with these other existing users who have already been using that 6 gigahertz spectrum. So how do we get up to the 10 gigabit speed? What are some of these new technologies here? So the first one is it supports spatial streams, up to 8 spatial streams in both upstream and downstream direction. It also adds the ability to do MU-MIMO in both directions. So with 11AC Wave 2, we had the ability for the access point to simultaneously send data to multiple client devices at the same time using different spatial streams. With Wi-Fi 6 now, it can go in both directions. So you can have the AP sending to multiple clients, and then you can have multiple clients sending data back to the AP simultaneously. So when you've got a network where you've got a powerful access point, but most of your client devices are cell phones or tablets or things like that, which have underpowered chips that don't support the full speeds, you can then divvy up that unused space or the unused spectrum, so multiple devices can transmit at the same time. So that's going to be limited by the number of spatial streams the access point supports. OFDMA, and we'll talk a little bit more about that. Resource unit scheduling, the ability to schedule when somebody broadcasts. We've increased the QAM, which is the modulation. So we're going from 256 QAM up to now 1024 QAM. So being able to cram more data in the same amount of bandwidth. Something called BSS coloring, which we'll talk about here in a second, and TWT, targeted wake up time. I don't think there's a slide on that. But one of the problems we have with the current generation of Wi-Fi is there's no organizational principle. Basically, a device listens to see if someone else is transmitting, and if it doesn't hear anybody else transmitting, it takes its turn. The problem with that is you add more and more devices, you run into situations where clients cannot are not within range of each other, but both are within range of the access point, so they both transmit at the same time. Or just situations where multiple devices listen at the same time, don't hear anybody else transmitting, so multiple devices decide to transmit at the same time. So with TWT, the access point has the ability to basically tell certain client devices, hey, take a nap, take a rest, your spot's coming up in a certain amount of time. So you have much more efficiency and less interference. So we'll go through some of these. So generally with Wi-Fi, as it exists before Wi-Fi 6, channels are broken up into 20 megahertz channels. So 802.11 BGA, those were all using 20 megahertz. Some of the speed boost with 11N was going up to a 40 megahertz channel. And then with 11AC, we had the ability to use 80 megahertz channels. So if you're doing MU-MIMO, again, only in the downstream direction with these older technologies, you still were stuck with 20 megahertz channels that you could limit people to on the spatial streams. With OFDMA, we're able to segregate the bandwidth as needed by the individual client device or application, all the way down to chunks of just 2 megahertz in size. So it gives us a lot more flexibility with how we utilize the available bandwidth that we're using and how that's assigned to the individual clients for much more efficient use and a lot less dead time. So we also have the ability to do what we call spatial reuse. So one of the biggest challenges we run into here is interference between access points, because access points are really powerful and they can send their signal really far. And you want to keep that power up to maximize speed by increasing your signal to or improving your signal to noise ratio. So the problem with that, though, is the access points themselves can cause interference. You can get interference up to just ridiculously long distances between access points. So Wi-Fi 6 adds something called BSS coloring, where basically the packets as they're being sent indicate who they're being sent to. So if your access point can listen and can see something come in and go, oh, wait a minute, I know that's not for me. I can ignore that. Let me focus on this other signal that's coming in that is for me. So it reduces the interference between access points. It's a really nice technology. So we've got some speed graphs here showing improvements. So what we're seeing here in the yellow line is with one access point, aggregated throughput of all the clients. And then on the orange line, doing the same thing, but using 11AC technology, so Wi-Fi 5 technology. So as you see here, as you increase the, whoops, I don't have my laser pointer on, there we go. So as you increase the number of clients here at the bottom, the aggregated throughput actually drops over to, as you add more. And the reason for that just has to do with what we were talking about before with inefficient use of spectrum, inefficient ways of determining whose turn it is to broadcast, et cetera. So with Wi-Fi 6, your maximum throughput that you can get remains the same as you add more client devices, where with the older Wi-Fi technologies, as you add client devices, the efficiency actually becomes worse and the aggregated throughput goes down. So this is just showing here the same information, but visualized on a per client basis. So what's the individual thing? And then again, you see each client, as you add more client devices, Wi-Fi 6 in the yellow here outperforms the older 11AC technology considerably. And then this is taking us up to 2 access points, splitting those devices between the access points, and it's the same thing. Because of BSS coloring and some of these other technologies, the aggregated throughput remains the same even as you add more and more devices, where again, if you're using 11AC technology, as you add more devices, the aggregated performance goes down because of the inefficiencies in the older standards, the ways multiple clients interact with each other. So here's just a quick breakdown of performance in a couple different situations. So Wi-Fi 4, in theory, could get you up to a maximum speed of 600 megabits using 4 spatial streams. Wi-Fi 5 or 11AC Wave 2 could get up to 6.9 in theory. And then Wi-Fi 6 gets us up to 9.6 gigabits per second in theory throughput. And this is just showing here, if you're doing a 2x2 80 megahertz, 11N was 108 megabits per second. With Wi-Fi or 11AC, Wi-Fi 5, you got up to 866 megabits per second on the single radio. And then that same one now gets us up to 1.2 gigabits per second on a 2x2. So one important thing here when looking at Wi-Fi 6 stuff out there is not everything advertising itself as Wi-Fi 6 is really Wi-Fi 6. In the rush to get product out there, there were some consumer products pushed on the market advertising Wi-Fi 6 almost 2 years ago. These early first chips were based on an older version of the Wi-Fi 6 standard. And just in general, the chipset technology hadn't quite gotten there yet. So what happened is these older chips don't support all of the Wi-Fi 6 features, and in some cases, some very important aspects of the Wi-Fi 6 chipset. So in general, any product that was shipping before, say, August last year is probably using one of these Gen 1 chips that doesn't support all the features. And even some of the newer technology or newer products that are coming out there are using these older chips because they're cheaper. So they're advertising themselves as Wi-Fi 6, but you're missing out on a lot of the key technologies that Wi-Fi 6 make. So as far as Zyxel is concerned, all of our Wi-Fi 6 products are using the 2nd generation chips. They offer the full Wi-Fi 6 performance. And while the slide here is talking about Qualcomm Gen 1 versus Gen 2, it's the same story with Broadcom also. Their Gen 1s are missing many of, and oftentimes the exact same features that are now supported in the Gen 2 chips. The other thing is one of the biggest Wi-Fi vendors out there is getting ready to launch their Wi-Fi 6 products. They've only put the Wi-Fi 6 technology on their 5 gigahertz radio. Their 2.4 radio is still using Wi-Fi 4 technology as a way of doing cost cutting. So that's something else to keep in mind, because in 5 gigahertz, you're only going up 1 generation, right? With 2.4, you're getting a 2-generation boost in performance and technology that's going to be missing on those access points that don't have Wi-Fi 6 on that. So that's something else to keep in mind when you're looking at data sheets. Look for some of these features and look to make sure that the 2.4 gigahertz radio is using Wi-Fi 6 as well. It's not just on the 5 gigahertz radio. So that, guys, is it as far as the general overview goes. Now I'll start talking about Wi-Fi, our Wi-Fi 6 family. So here it is here. We've got 5 models of our business access points that support Wi-Fi 6, and we'll go through these a little bit here. I'm going to start based on basically the order in which, well, kind of like the order in which these launched here in the US. So Anonymous is asking a question here, going back to the previous slide. How do we identify if the 2.4 gigahertz radio is Wi-Fi 6 and not just on the 5 gigahertz radio? General, if you pull up the data sheet for the product, it should still indicate which 802.11 standard the 2.4 radio is looking at. The other way to do it is to just look at the speeds. So if it's using 11N technology, it'll be a multiple of 300. So if it's a 1x1 radio, it'll be a 300 megabits speed claimed on the 2.4. If it's a 2x2, they'll claim 300, or excuse me, if it's a 1x1, it's 150. If it's a 2x2, it's 300. 450 for a 3x3, and then 600 for a 4x4. So multiples of 150, whereas Wi-Fi 6 is not multiples of 150. Anyway, so we'll start going through these. So I've grouped them kind of in the order in which they launched, but it's more based on the technology that they're using. So we'll start off by looking at these three here first. This will be a good introduction here for you. So the NWA 110AX is available now, should be available at all of our major distributors. It's a 2x2 on both radios, Wi-Fi 6. It is Nebula Flex, and it offers our filtering technology that helps deal with interference from neighboring 5G channels. So if you've been through one of our AP presentations, you've seen a similar slide to this before. If you've ever held our equipment and held one of our competitors' equipment, even more expensive stuff like Meraki or Ruckus, you will notice our products weigh a lot more. So there's a reason for that, and it has to do with the way we've built the products. So when you're dealing with solid state technology like this, there's a couple of points of failure on them. So one of them has to do with the capacitors. A lot of the capacitors out there are electrolyte based, so those can leak or dry out over time. We use only solid state capacitors in our design. But the other big cause of failure over time is heat fatigue, right? You've got these really warm chips in there. You've got something stuck up on the ceiling. So what we do is, you can just barely see it here, but we've got a big metal plate that acts as a heat sink, pulling heat off the PCBA and a number of vent holes across the back to make sure that heat exits there. So it keeps the heat down, where some of our competitors, not only do they not have a heat sink, they don't even have vent holes in their design. So they can advertise them as outdoor, sort of. And it does reduce the amount of time that the product's going to last before you start encountering failures. The other thing you'll see when you look at our board is we've got a lot more shielding around the chips on the PCBA, both to protect from interference from LTE and 5G radios that are operating on nearby bands, but also to help with EMI. So that gives us a little bit of a performance boost. Then on top of that, we've got another big chunk of metal. It kind of acts as a heat sink. It also acts to help distribute noise, but then we mount our antennas to that. Where most of our competitors, even our more expensive competitors, they mount their antennas directly to the PCBA, where they're much more likely to pick up some EMF, which can result in worse signal to noise ratio. So by moving the antennas off the board and mounting them onto a noise spreader, it gets us just, again, that much little bit better performance. So it doesn't maybe help you if you've got a good strong signal, but those edge cases, it makes a big difference for. And then we've got some various technologies in there to help with surge protection and electrostatic discharge. So if you're new to Zyxel, you may be wondering what Nebula Flex is and why I called it out on the previous slide. So Nebula Flex products are products that can be either managed directly through the web GUI, through a command line, or can be managed with our Nebula Cloud. So the Nebula Cloud interface is a free cloud platform. It allows you to manage an unlimited number of customers, an unlimited number of devices, does updates over the cloud, everything. So there's no local configuration if you want to use the cloud. So you get the options. You can standardize on a single piece of equipment. And for those customers you want standalone, you can do that. Those customers you want cloud, you can do that. Putting it into the cloud mode is very, very simple. You simply scan a QR code on the device or on its box, assign it to your customer. And when the access point boots up, it'll see that it's been assigned to a customer in the Nebula Cloud, and it will automatically put itself in Nebula mode. So there's no configuration you need to do to the access point. It'll handle it all automatically. And then at any point you decide you don't want it in the cloud anymore, you can unregister it from the cloud, and it'll automatically detect that and boot back into standalone mode. So the next model here is the WAX 510D. It's got the same sort of radio performance. It's a 2x2 on both radios, but we've upgraded the antenna technology on this guy to what we call dual optimized antenna. And this is not Nebula Flex, this is Nebula Flex Pro. So again, the same sort of breakdown here on the design. I won't won't repeat myself there. But generally, most access points are designed to be mounted on a ceiling, and their antennas are optimized based on that scenario. So they radiate out coverage in a nice sort of umbrella shaped pattern out from the access point. Unfortunately, here in the real world, we run into situations where we don't get to mount these access points on the ceiling for whatever reason, and we end up having to mount them on the wall. The problem with that is the antenna pattern really is suboptimal for that. You don't get good coverage out in the area you want to cover, and you end up sending a lot of the signal up into the ceiling or floor, where it's either being absorbed and lost, or if you're in a multi-story building, it's causing interference on the floors above and below you. So with dual optimized antennas, we have two sets of antennas built inside the access point itself. One that's optimized for ceiling, one that's optimized for a wall installation. So you can choose which antenna pattern to use based on where you've installed each individual access point. So Nebula Flex Pro, it's the same story as Nebula Flex. So products that are designated Nebula Flex Pro include 1 year of our Nebula Professional Pack out of the box. So that's an optional license that you can add to the free Nebula that unlocks a number of features primarily aimed at MSPs. It's a lot of reporting, advanced logs, more diagnostic capabilities. So it's not something you necessarily need, but if those are features you want, Nebula Flex Pro APs come with 1 year of that. You can always add it though as a separate license purchase on the regular Nebula Flex APs. So you're not locked out of that on the other model. And then the other thing Nebula Flex Pro does is it also indicates that the access point can be managed with a controller. So you've now got the flexibility of standardizing on one AP, and depending on the customer, using it as a standalone AP, using it as a cloud managed AP, or using it as controller managed, either with our NXC controllers or with our, most of our Zywalls now have a access point controller built in on them. So either way of doing things. So the WAX 510D, we're positioning this against the Aruba 505 Wi-Fi 6 AP and the Ingenious 357 and the 220. So all of these are 2x2 dual band access points using Wi-Fi 6. Ingenious though is using the older Gen 1 chipset, so it doesn't support upstream OFDMA, upstream MIMO, or BSS coloring, and probably a few other features. Only we are offering a dual optimized antenna. The other guys are just using standard static antennas. And we've got a little bit of better output power than both of these guys when it comes to things there. So this is just showing performance. We're in the orange. Orange is going to be wall mount antenna pattern. The yellow is going to be ceiling mount antenna pattern. And then the HP Aruba is the blue. So you can see here on 5 gigahertz, both on transmitting and receiving. We do a little bit better than Aruba does. Same thing on the 2.4. So next up is the Big Daddy. This is our first access point that we launched way back in January. This is our most powerful and still our flagship Wi-Fi 6 access point. So this doubles the number of spatial streams. So now we're at 4 spatial streams for both radios. It adds our smart antenna technology in there. It gives you a 5 gig Ethernet uplink and is Nebula Flex Pro. So you can see here, excuse me, here's the design. Now, the Wi-Fi, this particular model, because of how heavy duty it is, it requires a 802.3 BT PoE or an AC power adapter in order to be able to operate at full speed. So it will still work with a 802.3 AT PoE source, but it'll operate at half speed because there's not enough power to run it at full speed. So that's something to keep in mind there. Other sort of interesting things with this guy here is we support Bluetooth low energy. So if you've got an opportunity to use BLE beacons, that is something we can work with you with to deploy with this. It also, unlike all of our other access points, not just our Wi-Fi 6 ones, this is our first access point that adds a third radio that's dedicated just for doing channel monitoring and scanning and things like that. But otherwise, the design is very similar to the other models here with moving the antennas off the PCBA onto above a shield, having a heat sink or heat spreaders both behind and above the board, and enhanced RF shielding on the board itself. So I want to talk a little bit about smart antenna for those of you that might be new to Zyxel. The smart antenna technology is something that you usually only see with us and with Ruckus. So a lot of people aren't that familiar with the technology. It's designed to increase capacity, increase coverage range, reduce interference. So as we talked about before, your typical ceiling mount antenna has sort of a circular umbrella pattern. If you're using a directional panel access point, those are generally focusing the beam in one particular direction, such as our, let's skip that. So smart antennas, so instead of just having this one antenna pattern or two in the case of dual optimized antennas, has the ability to actually use hundreds of different antenna patterns. So it can use a different antenna pattern for each individual client device. So the algorithm that we use is heavily focused on finding the optimal antenna pattern based not just on where the client device is in regards to positioning from our access point, but also where other sources of RF interference may be coming from. And then chooses a pattern based on that that optimizes signal in the correct direction while avoiding sources of interference that may cause problems with the reception. So because of this, when using smart antenna, you can fit a lot more access or a lot more client devices on an access point. You can also use a lot more access points in a small area. So these are ideal for things like conference rooms, business centers, expo centers, anywhere where you've got a lot of devices on Wi-Fi in a small area that you want to cover. So now you're going to say, well, Sean, doesn't Wi-Fi 6 solve a lot of these issues? So this stacks on top of the benefits you're getting from Wi-Fi 6. So you're getting a double whammy of benefits. You're getting the smart antenna benefits and the Wi-Fi 6 benefits. So here's a breakdown of our different competitors: Cisco 9115, the Meraki MR45, the Aruba 535, or the Ruckus R750. All of them are Wi-Fi 6 based. I believe all of these are true Wi-Fi 6. Only us and Ruckus offer the smart antenna technology. We offer a little bit higher output power than all of our competition does. All of these are 4x4. And we are offering that 5 gig uplink port. You'll notice when you go through here, neither Cisco does not offer 5 gigahertz uplink points. They only offer 2.5, as does Ruckus. So only Aruba is offering the 5 gigahertz uplink that we have there. So we've got some performance maps here. Again, we're comparing us to HP Aruba. And as you can see here, some big performance benefits here. It should be noted, though, that at least in this comparison here, this is 2.4 gigahertz. The Aruba is only 2x2 on the 2.4 radio. We've got a little bit benefit there that we're 4x4 versus 2x2. But the 5 gigahertz is exactly the same between the two. Both are 4x4. And again, you see significant performance increases there. So as I mentioned before, if you want to use the WAX 650S at full speed and you want to do PoE, you need to use 802.3 BT. And also to get maximum performance, you're going to want a multi-gig Ethernet connection. So the solution to that from the Zyxel portfolio is the XS1930-12HP. It provides the 802.3 BT PoE. I forget what the overall power budget is, but it can support multiple WAX 650S access points. And it also supports multi-gig across all of those ports. So we do have a promo running right now where if you buy 4 of the WAX 650S, we will give you this switch for free. And I'll talk a little bit more about that at the end of the presentation. So quick summary here. Same speed between the NWA 110AX and the WAX 510D. The benefits of jumping from the 110 up to the WAX is that you're getting the dual optimized antenna and you're getting Nebula Flex Pro license out of the box and the ability to work with a controller. Then when we add the WAX 650S in there, the benefits are doubling the speed from 2x2 to 4x4, faster uplink, 5 gig uplink port, smart antenna technology, the dedicated scanning radio, and the Bluetooth low energy radio. So it's a big boost in price between the two, but also in performance. So now we'll talk about the 2 newest members of our family. The NWA 210AX is available now. The WAX 610D Has been available, but it's really limited as far as stock goes. We should be getting more of these in here soon. I think locally we're sold out. Some distribution may still have some of these in stock though. So let's go ahead and talk about these two new guys. So now, before we talked about an NWA 110AX, this is the NWA 210AX. It's still Nebula Flex, but we've boosted performance on the 5 gigahertz radio. The 5 gigahertz radio is a 4x4. The 2.4 is still 2x2, so you're doubling speed on the 5 gigahertz radio over the NWA 110AX. We've got a 2.5 gig uplink port versus a 1 gig uplink port on the other one. Otherwise, similar design, similar internals as far as all the stuff we talked about with the shielding and the heat spreaders and all of that. And then we've got the WAX 610D. So very similar to the NWA 210AX, but it adds, just like before with the previous grouping, this adds dual optimized antenna and Nebula Flex Pro. And again, same sort of internal industrial design. It's designed to help boost performance and help prolong the life of the product itself. So again, main differences here between each other is adding the dual optimized antenna and the Nebula Flex Pro. So this now gives us our complete and total family here of Wi-Fi 6 access points. We are not planning to add anything new to this lineup anytime in the near future. So this is going to be our Wi-Fi 6 lineup for some time. So if you're looking for just Nebula Flex, we've got 2 models for you here. And then if you're going to Nebula Flex Pro, we've got 3 models that out of the box support Nebula Flex Pro. All of our new APs are using a new mounting bracket design. Now, the mounting brackets aren't necessarily interchangeable between the different models, but the general design is the same. So basically, this new mounting bracket is designed so you can easily mount it to a wall, mount it to a ceiling. You can add our, what do you call these, our T-bar mounting bracket kit here. And then you can clip this onto the T-bar so you don't have to poke any holes in the drop ceiling. But this is also designed to be mounted directly onto a outlet box. So a little rectangular junction box or a standard round junction box. So a lot of flexibility with where this one mounting bracket is going to work. And this applies to all of our Wi-Fi 6 APs. I think we've got a little animation here. There we go. Okay, guys, we're almost done. So this is a promo. The promo is expected to end the end of this month. I suspect we're going to extend it, but I haven't gotten official word that we are yet. So in order to take advantage of this promo, you must be a member of the Zyxel Partner Program. It's available through D&H, Ingram, and Target. So we've got 3 different bundles here for you. We've got bundle 1 here, which is our WAX 650S access points. If you buy 4 of them, you get our XS 1930-12 HP switch free. So you're getting the 10 gig PoE 802.BT PoE switch, so you can operate these at full speed. Bundle 2 is purchase 3 of the WAX 650S, and you get a 4th one for free. And then we're also offering a bundle on the WAX 510D for those that don't need that horsepower there. So you buy 5 of these access points, we give you the GS 1350-12 HP switch free to go along with it. So with these here, it's very important. These have to be purchased with special bundle SKUs. These are not something you can just buy with a standard SKU. So when dealing with your rep at distribution, be sure they're hooking you up with the promo SKU. So I just checked stock yesterday, and as I was seeing things here, bundle 1 and bundle 2 are available currently in stock at D&H. And then the takeoff bundle here is something that they can order in for you. I checked Target. Target has bundle 1 and the takeoff bundle in stock. Bundle 2, they were out of stock on, but again, that can be ordered and we can fulfill it here shortly. So those are available there. Ingram didn't have any of these in stock, but Ingram can order them for you. So guys, that ends today's presentation. I'll get to the questions here in just a second. But if you do have some more questions, send them in via the Q&A interface. I do want to draw attention to our forum. So forum.zyxel.com. In theory, this is just another user-to-user forum for guys to talk to each other and give advice to each other and things like that. But we do have it monitored by both our product management team at our headquarters in Taiwan and by our R&D team. So when you're posting stuff there, don't be surprised if somebody from HQ responds to you or asks for more information. And it's a great place to post feedback. So not only is it just you posting feedback, but hopefully other users will see your suggestion and agree that it's something that's needed and help give our product management team in Taiwan a little bit more visibility as to what people want to see in the product going forward. And then as always, my email's there, seanr@zyxel.com. Feel free to reach out to me offline with any questions, comments, suggestions for webinar topics, etc. So onto the Q&A window here. Let's see what we've got. So first one was asking, are the slides available post-webinar? So the answer to that is yes. This webinar will be posted to our YouTube site, or our YouTube channel, I guess they call it, probably tomorrow, but probably Monday at the latest. So they're there. If you actually want a copy of the slide deck itself, reach out to your salesperson, David or Jacob, and they should be able to provide a copy of that to you. So Paul has got a question here. How does roaming work across Zyxel AX models? Does it work with a mixture of AX and AC models? Is it okay to enable 802.11 kV for future growth, even if you have only one AP now? So the answer to all of those questions is yes. So you can go ahead and enable those even if you don't plan to use them now. It's not going to have any sort of significant negative impact on performance there. But yeah, all the models are capable of roaming between them. It doesn't matter if you're mixing and matching Wi-Fi 6 with Wi-Fi 5. In general, roaming itself is actually handled by the client device. So it's the client that determines when it switches from one access point to another. I know Apple products for a long time have been notorious for connecting to the first APVC and not roaming no matter how bad that connection got. So there are some different technologies, as you mentioned there, with such as KNV and some of the newer stuff now, which helps the AP guide client devices that support it to different access points. And then we also have some of our own tricks. So for instance, if you go into Nebula, you can set signal thresholds and things like that. So we can go through there and we can determine, wait a minute, this client device's signal is getting poor, and we can kick them and try to help prompt them to choose to roam to another access point, prevent them from reassociating immediately to help increase the chances of them doing that. And then we've got the various 802.11 specs that we support for fast roaming and things like that. So let's see here. Paul's got another question. Are there any special settings to best support older 802.11 products, or is everything wonderful no matter how we configure it on the Wi-Fi 6 AP? Yeah, so there's nothing special you need to do as far as backwards compatibility goes. It's going to handle all of that itself pretty well, as long as you want backwards compatibility. You know, the challenge with this, just like with any new 802.11 tech, is to get the full benefits of all this new technology. You want as many of the client devices on that AP to also be Wi-Fi 6 and to support those features. But yeah, it'll still work fine with legacy devices connected. You just don't see the complete maximum benefit that you would if everything was Wi-Fi 6. And let's be honest, it's going to be a while before, you know, the majority of devices out there have Wi-Fi 6. I think, like, for instance, this year's iPad is still an 11AC radio in there. Some of the phones with Wi-Fi 6, the Wi-Fi 6 chip they're using doesn't support all the features. So, you know, it's going to be time for them to optimize those chips, get all the features in there, and get them efficient enough that you want to actually use them on mobile devices. So for a lot of this Wi-Fi 6 stuff, we're talking about the benefits going forward in the future as the technology changes and people are using new phones, new tablets, new devices that support all of these features. Another question here. For new products, how can you tell which configuration modes are fully supported? So that's a good question. Reach out to your sales rep, or if you're dealing with Marcus can kind of help you out with that. So what he was asking about is using their controllers to be able to manage these devices. So the first device, so all of these APs can be managed with either an NXC controller or with a Zywall product in the controller mode. They're using a mode that we call forward compatible mode. So it supports all of the core features and settings, SSID, channel, things like that. but some of the more advanced Wi-Fi 6 features, such as enabling or disabling OFDMA, are not supported necessarily on the current firmware on the controllers. So I think right now the NXC support all the models, I want to say. I'm trying to remember if the firmware came out. We supported the first three, the WAX 650S, the 110, or excuse me, the WAX 650S and the 510D. Those are supported on the NXCs, and I think we just released the firmware that supports all 5 models. If not, it will be released here shortly. And then on the Zywalls, those are lagging behind by quite a bit of time there. So for the time being, I forget the exact breakdown, but I want to say this month they can support the original first 3 models, but the newer models won't have full support for all the features until next year sometime with a firmware update. Your sales guys can get that information and give you the firmware versions. I don't have it off the top of my head. How important is client for Wi-Fi 6? So again, to get the maximum benefits of Wi-Fi 6, you want as many devices to be using Wi-Fi 6 as possible. The more Wi-Fi 6 devices you have on a Wi-Fi 6 AP, the better it'll perform. The more Wi-Fi 6 APs you have in a building or within a limited area, the more benefits you'll have that way as far as some of the interference technologies they have to prevent the APs from interfering with each other. Any benefits for Wi-Fi 6 client devices coming to Wi-Fi 6 APs? Not a lot out of the box. You're not really going to see a lot of things there. But as the more and more Wi-Fi 6 client devices get on there, those Wi-Fi 6 client devices will be more efficiently using the airtime in the spectrum. So that will then create a boost for the Wi-Fi 5 products. So there'll be less contention between Wi-Fi 6 as the mix becomes more and more Wi-Fi 6 leaning. So Mark is asking here, I compared a competitor's Wi-Fi 6 and Wi-Fi 5, and the Wi-Fi 5 device had faster speeds. Is this due to IoT device not being 6 compatible, or will we not find this with Zyxel products? I'm not sure I understand the question fully, but let me take a shot at it here. So a Wi-Fi 6 access point isn't necessarily going to be faster than a Wi-Fi 5 product, just based on the spatial stream. So a slow Wi-Fi 6 AP will be slower than a really fast 11AC Wave 2 AP. So you've got that there. And then also, again, in order to see any of the performance and speed boosts, the client needs to be able to support it as well. So they need to be Wi-Fi 6. They need to have, the maximum number of spatial streams, and they need to support all of the new technology. So if you're not, your client device, for instance, in your phone, you may have a 4x4 access point, but only a 1x1 Wi-Fi 6 chip in your phone that you're testing with. So you're only able to take advantage of one of the 4 spatial streams, for instance. Or you may find your client device doesn't support upstream MIMO, for instance. So you may see a performance hit there. So I hope that answers your question. If not, type something else up here, maybe define it a little bit better, and I'll see if I can better answer that. Okay, Tim has a question here. Any advice for selling Zyxel with a UC AAS solution? I know the AAS is as a service. I'm not sure what the UC is standing for there. My mind is going blank. So maybe tell me what UC is, and then maybe I'll have some suggestions. Maybe I won't. There we go. Universal Communications as a Service. So that is a term I am not familiar with. So no, I guess I can't answer that. Send me an email offline. Again, my email's up there on the screen. It's seanr@zyxel.com. Let me look into that. Maybe I'm used to it being called something else, but let me look into that, and then I can get back to you on that. So just send me an email directly, and I'll try to answer that for you. Or I'll get our sales engineer involved. Who's probably a little bit more familiar with that than I am. I'm not sure which one Paul here is responding to, but here we have higher output power, but unless we also have higher sensitivity, we might not hear the client signal. So yeah, that's a general Wi-Fi issue and something people run into a lot. Again, your access point is really effing powerful, right? Generally, your access point these days is doing at least 1 watt of output power or pretty close to it. But your iPhone or your Android, Samsung phone, whatever your mobile device is probably putting out 50 milliwatts or less. So there's a huge disparity in how far that signal can go from the client back to the access points. That's why you run into these situations where your phone shows it's got a Wi-Fi connection. It's showing maybe 3 bars, but the connection sucks or doesn't work at all. And that's because your phone is reporting how strong the signal is that it sees coming from this really powerful access point. But it doesn't know how far its signal is going back to the AP and how well the AP is able to hear that. So again, that's one of the settings we've got in our access points. You can set a signal strength threshold and have the access point automatically boot somebody once their signal strength gets below something. So that's a signal strength coming back to the AP. And then hopefully they're near another access point on your network and will automatically roam to it. But yeah, it's a very common problem, and there's nothing Wi-Fi 6 is really going to do with that. Higher sensitivity on the radio on the AP helps a little bit with that, but not a whole heck of a lot. It helps the signal to noise ratio. It helps a lot with signal to noise ratio when you've got a sort of noisy environment. Okay, so Tim here was mentioning doing VoIP earlier. So yeah, voice over IP or voice over IP over wireless LAN or VOW LAN is a really contentious, hard thing to do with Wi-Fi, and it's simply because with most technologies that you're using, whether we're talking web browsing or emails or even streaming something live from YouTube, it's primarily a one-way communication that is fine with it being handled in bursts. So when you watch a live stream of something on YouTube or wherever, you're actually watching it on a slight delay as the packets come in and they get buffered. So then when it plays back smoothly. So if those packets come in slightly out of order, or some of those packets get dropped and need to be rebroadcast, it doesn't make a huge difference for most things. Voice is the exact opposite of that. Voice is probably only using, somewhere around 56K. So it's not bandwidth dependent at all, but it's happening in real time or as close to real time as we can make it. Since it needs to be two-way communication. So because of that, we aren't able to buffer things. So it becomes really sensitive when packets get dropped and things like that. So as we go and move into Wi-Fi 6 and the Wi-Fi 6 clients, we solve a lot of those issues, right? So we have the BSS coloring. So the access point knows whether it's picking up a signal from somebody that's on a different AP versus the signal it wants to listen to. So that helps with the quality there, reducing drop calls. TWT makes sure that the airtime is being used efficiently. OFDMA again is using the airtime efficiently. Upstream MIMO will allow multiple client devices to transmit at the same time back to the AP. So you're more efficiently using the bandwidth. They're not having to wait as long. So Wi-Fi 6 is going to solve a number of these issues for doing voice over wireless LAN. Although in order to get the full benefits of this, you're going to need to wait for the Wi-Fi devices that are doing the voice to support Wi-Fi 6 and et cetera. But it is going to be a huge change going forward as far as providing voice over wireless LAN. It should make it a much smoother process and solve a lot of those issues that we know people run into doing voice over Wi-Fi right now with Wi-Fi 5 technology. Okay, that looks like that's it for the questions. If there's anything else, if you're typing something in, go ahead and pause, highlight it, and just paste it into an email, and I'll just take care of it offline. If you send me something and I don't respond within 1 business day, send it again. We've got a ridiculous amount of spam filters and security filters on our email these days. So there's always a chance that something gets snagged and I don't see it. Generally sending it again, it'll get through. We even have stuff that doesn't even end up in quarantine. It just gets stopped by Barracuda and never passed on or notified about it. So I'm not ignoring you. Just send it again. And if you send it again and I still don't respond, loop in somebody in our organization that you talk with, Jacob, David Chen, and they'll let me know and we can track it down and get the answer for you. But otherwise, guys, that's it. And again, if this will be posted up to YouTube, probably by tomorrow, but Monday at the latest. And then you can always ask if you need a copy of this for some reason, ask your salesperson. They can help arrange that for you. Thanks, guys.